YouTube viewers, it is Crystal here, and I'm making a video on the Kaggle competition. It's Playground Competition, Season 6, Episode 8, which is August 2026. And so basically, in this competition question, is you have to predict on whether someone is likely to become addicted to a smartphone. And so what you have to do is you have to predict upon the probability. And then when you predict upon the probability, it is a classification model, but instead of saying yes or no, you're going to predict on the probability that it is yes. And so this is a chemical competition. I have actually saved it to my Kaggle account. I'm not using Kaggle that much anymore because I'm busy doing other things, but I still do the playground competition every month just to try to keep my skills up. But whenever I was looking at Kaggle the other day, their menu selection has a lot more items in it, so I might try to make an agent at some point. But I do have lots to do, and so basically I'm working on all of the other things that I have to do as well, such as working on Excel. I did a basic Excel course and an intermediate Excel course, and my next project is going to be an advanced Excel course, so that should be interesting. So if you like Excel, I would highly recommend that you look on my playlist and look at all of the Excel courses that I have in my playlist. So what we're going to do is, whenever I carried out the competition and I submitted my work to Kaggle, I got a 95 percentile, which wasn't too bad considering the fact that the highest percentile was 97%. So I was only 2 points less than the highest percentage. So I thought that was pretty good. So the first thing that you want to do is you want to write your problem statement. And your problem statement is predict on whether someone is likely to become addicted to a smartphone. And then after we have defined our problem statement, then what we're going to do is we're going to import our libraries. And so since the CSV files that form the competition question have numeric and object columns in them, I decided that I was going to use the catboost classifier for this. And the reason why I'm using the catboost classifier is because the catboost classifier works on both numeric and object columns. So that's the good thing about the catboost classifier. So the first thing we're going to do after we define our problem statement is we're going to have to import our libraries. So we're going to import pandas as PD, which does your data processing. We're going to import NumPy as MP, which performs your numeric processing. We're going to import OS, which goes into the operating system. We're going to import catboost classifier, which is going to be your model. We're going to import sklearn, which gives you your machine learning functionality, and we're going to import matplotlib.pyplot as BLT and Seaborn as SNS, which are going to enable you to visualize the data. So after we have imported our libraries, what you want to do is you want to use OS to retrieve the files. And so there are 3 files in the directory for the competition, and the files are train, test, and sample submission, and they are CSV files. So after we have retrieved our 3 files, then what we want to do is we want to convert our CSV files to data frames. So what I want to do is I want to set my data frame up so that you can see every single column. So you do pd.set_option brackets display max columns, comma, none. And so that sets it up so you can see every column of data. And then we're going to use pandas to convert the 3 CSV files to data frames. And we're going to use the the pd.read_CSV function to do that. And so we're going to convert the CSV files that we have retrieved into data frames. And the 3 data frames that we're going to create are train, test, and submission. So train is going to be what you're going to train your data on. Test is going to be what you're going to test your data on. And submission is the format that Kaggle wants to see when you submit your work. So the train and test data frames have an ID column. You don't need an ID column because Pandas automatically indexes every row of data. So we're going to drop the ID column to make it easier to train and test the data. You're going to have less data to train and test, which is a good thing. So we've got our trained data, and the trained data has mostly numeric column features, but the last 3 features are object. So the last 3 features being gender, stress level, and academic work impact are objects. And so because of that, that's the reason why I decided to use catboost classifier. And you've also got your addicted label, which is your target. We've got you do train.info brackets, and what that does is that tells you what type of column each column is. And so you can see all of the beginning columns are floats, the last 3 columns are objects, and the target is an integer. So we check for null values. You can see that we've got quite a few null values in every column except for the addicted level. So what we're going to do is we're going to drop all of the null values. So train equals train.drop_NA. And then so we're going to check for null values again, and you can see that we don't have any null values after we have dropped all of the null values. And then so we're going to check the shape of train, and you can see that we have significantly fewer rows of data than you had before we dropped the null values. So I had a choice. I could either drop the null values or I could impute them. And so I decided that it was better to drop the null values. And so that's what I did. But if you wanted to impute the null values, you can do that too. And you can check to see what score you get. You can check, do you get a better score if you impute the null values or drop them? But I just decided to drop them. I thought it would be better to drop them. And so now I'm going to describe the train data frame. So when you describe the train data frame, you just get a little bit of descriptive statistics. So you get a count, which tells you how many rows of data you have, the mean, which is telling you the average, the STD, which is the standard deviation, the minimum value, the 25 percentile, which is your first quartile, the 50 percentile, which is your second quartile, your 75th percentile, which is your third quartile, and your max, which is your fourth quartile. So if you want to check the statistical value every row of data, then you can do that. And then I think that what happens is when you check describe like this, it only checks the numeric values. It doesn't check the object values. But if you go into the internet and you check on describe, if you want to see all of the columns of data, I think there actually is a way that you can see all of the columns of data, but I can't show that to you right now. But you can look it up, and when you look up describe, they give you hyperparameters, and you can set the hyperparameters up so it'll show you all of the columns of data if you want them. So we check our test file, and this is the data frame that we're going to use to test our data. And as you can see, we've got lots of null values in the test file as well. So we check for info. So when you check info, you can see that the layout of the test data frame is very similar to the layout of the trained data frame. And the reason why it has to be, because if you're going to, the layout of the test data frame and the trained data frame need to be essentially the same, so you can train the data on the trained data frame and then test the data on the test data frame. We're going to check for null values, and you can see that we've got quite a few null values in every single column. So in this instance, we cannot delete the null values. And the reason why you cannot delete the null values is because when we enter the competition, we have to enter the competition and submit our work the way Kaggle wants us to submit it. And so Kaggle wants us to submit the work using every single row in the test data frame. So what we're going to have to do is we're going to have to impute the values. So what we're going to do is we're going to put a for loop, and then for every for loop in the test data frame, if the D type of the column is float, then what we're going to do is we're going to put the mean of the column in the null value. If the D type of the column is an object, then what you're going to do is you're going to fill that object with the most frequently used object value. And so that's how we're going to do it. And then we're going to again check for null values, and you can see that we don't have any null values in this instance. Now we're going to describe the test data frame. And so when you describe the test data frame, it's going to be very similar to describing the trained data frame. And so you're going to have the same count, mean, standard deviation, minimum, 25%, 50%, 75%, and maximum. And you can check your statistics there. So now we're going to print the submission, and this is what Kaggle wants to see when you submit your work. So Kaggle wants to see an ID column, and the ID column is going to be the value that is in the test data frame before we have dropped the ID columns. And the addicted label is going to be a probability of whether someone is likely to become addicted to their smartphone. Now what we're going to do is we're going to analyze the data frames. So we're going to define a function at fmtx, and we're going to return a value. So what we're going to return is a percentage. So you're going to return a value of x, and you're going to format it as x, comma, total times x over 100. And so basically what that's going to do is that's going to give you a percentage of a pie chart, a value. So we're going to, the first thing we're going to do is we're going to analyze all of the columns of data in the trained data frame. So if the train column, the number of unique values in the train column is greater than 5, then what we're going to do is we're going to create a histogram. And the title is going to be column, the X label is values, the Y label is frequency, and then you're going to show it. Otherwise, so that means the number of unique values is less than 5, or 5 or less, then your title is going to be your column. Your total is going to be the value counts of the column, dot values, dot sum, brackets, and then you're going to make a pie chart. So the first, if you have more than 5 values, it's going to be a histogram. And if you have 5 or less values, it's going to be a pie chart. And we're going to show it. So basically what we're going to do is you're going to see the histogram for all of the columns. So for the age, you can see that the ages and the ages range from 17.5 to 35. So these are young people. And you see that it sort of makes a uniform distribution. And you're going to check daily screen time hours. And it's going to be from 0 to 14. And you can see that it's close to a normal distribution, but not quite. So we're going to see the social media hours. So you can see the number of social media hours. The maximum is 2. Well, the most frequently used number is 2, but it can be anywhere from 0 to 8. I don't know what they do if someone uses social media more than 8 hours, but you can see that it is a right skewed distribution. So the more hours that somebody looks at social media, the less the frequency is going to be. And the major frequency, the most commonly used time is close to 2 hours. And then it starts to decrease after that. Check for gaming hours. That's how many hours they game. And so, again, that's anywhere from 0 to 4 hours. And it is a right skewed distribution. Work study hours. So your work study is going to be up to 6 hours where they're either working or studying. And it's going to be, again, a right skewed distribution. The sleep hours is going to be anywhere from 5 to 9 hours. And it's close to a uniform distribution, but not quite. The notifications per day is going to be anywhere from 0 to 250. And that's interesting because on my computer, I do not allow notifications on my computer. I do get notifications on my phone, but not a lot because I don't have a lot of apps on my phone. So since I don't have a lot of apps on my phone, I don't get a lot of notifications. But you can see it's sort of close to a uniform distribution. And then it says app opens per day. Anywhere from, I don't know what that means. I don't know if it means they open the app or that's how many apps they have open, because 175 apps seems like quite a lot. So I'm thinking it's like the number of times they open their app, but I just leave my apps on all the time. Weekend screen time is anywhere from 0 to 17.5, and sort of the median value is between 7.5 and 12.5. You can see that it's sort of like a normal distribution. It's close to a normal distribution. And then gender. So you can say that it's about a third male, female, and other. I don't know why somebody would want to pick other, but they did. And then they have stress level. And then again, the stress level is about a third, low, medium, and high. Now we're going to say academic work impact. So it's about half yes and half no. And then your addicted label. So you have about 71% people are addicted and 29% people are not addicted. So that's interesting, and that's your target. So now what we're going to do is we're going to check the same values on our test data frame. And so again, if it has greater than 5 unique values, then we're going to create a histogram. Otherwise, we're going to have a pie chart. So we've got the age, and the age is about 27.5. 25 to 27.5 is the highest number. So basically, you've got an age between 17.5 and 35. So what you're doing is you're asking for a young audience. Daily screen time, and the maximum is just less than 8 hours. It's your daily screen time. And I do have to use a lot of screen time because when I work, I'm sitting in front of a computer all day long. Social media hours, it's about between 2 and 3 is the maximum number of social media hours. So that's quite a bit. Gaming hours, it's just less than 1.5 hours gaming. So that's interesting. Work study hours, it's just over 2 work study hours is the maximum. Sleep hours, it's just under 7. So again, that's your maximum. Notifications per day is about 150 notifications per day. Apps open per day is about 100 apps open per day. So I'm going to take that to mean that they open an app. Weekend screen time is about less than 10 hours. So that's saying that they're looking on the computer a lot, or they're looking on their smartphone a lot. Gender is about 1/3 each, male, female, and other. Stress level is about 1/3 each, except for 38.9% is high, and 30% is low, and 30% is medium. So they have a high stress. Academic work impact, 55.5% is yes, and 44.5% is no. So I think that means that screen time is affecting their work and their education. So that is the histogram and the pie chart that we have made for every column. And as you can see, when we went through and looked at the train data frame and the test data frame, it seems to me that the test data frame is significantly different from the train data frame. So that's going to affect your accuracy as well. So what we're going to do is we're going to pre-process our data. So target equals train.pop addicted level. So that means you're taking the column addicted level out of the data frame. And then we're going to look at the top 5 and the bottom 5 values. So you can see that the top 5 values and the bottom 5 values. So now what we're going to do is we're going to initialize an empty list to store categorical columns on train data frame. So cat calls is an empty list, and we're going to iterate through the data frame columns for call in train.columns. If train call.dtype equals object, you're going to add the column to the list. So you're going to print call, train call.unique, and you're going to print call dot, train call dot in unique. So unique is the unique values, and in unique is the number of unique values. And then we're going to append it to the list cat calls. So you can see that here we've got 3 columns of data that are object columns. So gender has male, other, and female, and it has 3 unique values. Stress level is high, low, medium, and you have 3 unique values. And academic work impact is no and yes, and you have 2 unique values. So we're going to go through and we're going to complete the same exercise using the test data frame. So the only difference between this bit of code and the bit of code that we just looked at was in this one we're using the test data frame, and the other one we were using the trained data frame. So you can see with gender we have other, female, male. You have 3 unique values. With stress level you have medium, high, low. You have 3 unique values, and academic work impact is yes and no, and you have 2 unique values. So we're going to find the columns of D-type, integer, or float. So numCols is an empty list, and we're going to iterate through the data frame columns. For call in train.columns, if train call.dtype equals int or train call.dtype equals float, we're going to add the column to the list, and we're going to use the append function, and then we're going to print out the columns. So the columns that are of a numeric D type are age, daily screen time hours, social media hours, gaming hours, work study hours, sleep hours, notifications per day, app opens per day, and weekend screen time. And then what we're going to do is we're going to one-hot encode the categorical columns of the trained data frame. So for call in cat calls, temp, we're going to create a temp variable equals pd.getDummies brackets train call.sType brackets int. Train equals pd.concat brackets train, comma, temp, comma, axis equals 1, and train.drop brackets catgalls, comma, axis equals 1, in place equals true, and train.shape. And then so now we have 17 columns of data, whereas before I think we may have had 13 or 14. So we complete the same process using the test data frame. And so we use all that. And again, we check our shape. And you can see again that we have 17 columns of data again. So what we have done is we have one-hot encoded all of our object columns. We've one-hot encoded those columns. And then we're going to convert the columns to an integer. And then so basically every column is going to be a yes or a no, because that's basically when you one-hot encode a column of data, you're going to have 3 columns that in each 3 column is going to be the categorical value. So yes will be either a 1 or a 0, and no will be a 1 or a 0. And male will be a 1 or a 0, female will be a 1 or a 0, and object will be a 1 or a 0. So that's what you're doing. You're one-hot encoding all of the object columns. And that's how it works using catboost classifier. So now we're going to define our dependent and our independent variables. Y is your target, X is your trained data frame, and because we've already removed the target from the trained data frame previously, and X test is your test data frame. And we're going to use train test split and sklearn to split the train, your X variable and your Y variable into training and testing sets, or training and validation sets. So X train, X val, Y train, Y val equals train test split, brackets X, comma, Y, comma, random state equals 42, test size equals 15%. And then we're going to check the shape of X-train, X-val, Y-train, Y-val, and X-test. And so you can see that in the training and testing data, you have 17 training, testing, and validation data. You have 17 columns of data, but in the Y variable and the Y-val and Y-train, you have only one column of data. So now we're going to define our model, which is a catboost classifier. So your loss function is going to be cross entropy. Your iterations, I set it up for 5,000. You can set it up for more if you want, but please keep in mind that the more iterations you have, the longer it's going to take to train the data. But if you want to use more iterations and see if you can get a higher accuracy, then go right ahead. Learning rate is 0.1, depth equals 6, and verbose equals 1,000. So that means every 1,000 iterations is going to print the data, print the result. And then we're going to fit our X-train and our Y-train into the data. So you can see that every 1,000 iterations, you're going to start out with 0, 1,000, 2,000, 3,000, 4,000, and 4,099. And it will set you up for, just to let you know that it's iterating it. And then, so we're going to make our predictions. So your predictions are going to actually be a probability. They're not going to be a classification. It's going to be a probability of whether or not someone is going to become addicted to their smartphone. So YPRED proba equals model dot predict proba brackets X val, and then we're going to be using the position number 1 of the output. And the reason why you use position number 1 is because Python numbering system starts with 0. And since the Python numbering system starts with 0, you have to use 1, which is really the second one. So we've got the probability. Now we're going to check the ROC AUC score using probability estimates. And so your ROC AUC score is 97%. And then now what we're going to do is we're going to create a pie chart of YPRED. So YPRED is going to be 71.2% as a 1, which means that yes, they are addicted, and 28.8% being 0, which means they're not predicted. So now we're going to create a histogram of YPRED. And this is your histogram. So this is the probability that somebody is going to become addicted to their smartphone. And you can see that there's a lot of positions in the 1 position. So now we're going to make predictions on the test set. So that's going to be what we're going to submit to Kaggle. So we're going to use exactly the same code that we used to predict on the validation set, but instead of predicting on the validation set, we're going to predict on the test set. And then what we're going to do is we're going to create a pie chart of the predictions. So you're going to have 74.1% as 1, which means they are predicted, and 25.8%, which is 0, which means they're not predicted. So you can see that the test set is somewhat different from the train set. So that's interesting. So now what we're going to do is we're going to create a histogram of the predictions. So again, this is a histogram of the predictions, and you can see you have quite a few predictions in the 1 area. So after we've done that, what we're going to do is we're going to prepare our submission. So submission addicted label equals pred proba. Submission.toCSV, which means you're going to take your submission and your data frame and you're going to convert it to a CSV file. and is submission.csv, comma, index equals false. And then you're going to convert that submission back to a data frame, and you're going to view it. So this is the submission that you're actually going to submit to Kaggle. And so when I submitted my work, I got a 95%, which I think is okay. I think 95% is okay. I could have tried to improve my score to make it 97%, but one way to improve it would be to train it longer. Like maybe instead of 5,000 iterations, try 10,000 iterations. But if you train it longer, then what's going to happen is going to take longer to train it. And so I don't have a lot of time because I'm a very busy person. Another thing that you could do to improve your score would be to use more data, more training data. But what I had to do is, because there were so many missing values, I just dropped all the missing values, so I didn't have very much training data. And I just had to make the decision to go ahead and drop all the null values, because you never know. If you've got a missing value, you don't know what is going to be in that missing value. So you could put a mean or a median or another thing to do, or like a K, like use the value that's close to you, or use the value that's one step away from you, or something like that. There's lots of different ways that you can impute data, but I just decided that the best thing to do would just be to drop all the null values, because I thought it would give me just as good, if not better, a score dropping all the null values. But because all of my null values were dropped, that means that I didn't have as much data to train. So there's lots of things that you can do if you want to try to impute your null values and see if you get a better score. Well, that's entirely up to you. So that concludes this video. I'll be back next month to give you another video on Kaggle's playground competition. And if I have the time, I might actually try to do some more competitions as well and study some code, like learn about agents and things like that. So thank you so much for watching this video. If you like my video, please like and subscribe, and I will be communicating with you very soon.